All right, guys, I want to do a quick explanation of each of these problems since I'm not able to do a review sheet, and this video will be up on YouTube, of course, because you're there looking at it. Solve by factoring, we want to use the zero product property, so we first need to make sure that it's equal to 0, and when we are equal to 0 here, so we're good to start. We want to find the factors of negative 45 that add to be positive 4. Those are 9 and negative 5. All right, so we'll set up our factoring here. 3r times r will give us 3r squared. To get the 9r, we need a positive 3 here. Get the negative 5r, we put a negative 5 there, and that'll give us what we're looking for. All right, so we have those two factors, and using the zero product rule, multiplying these together, setting each factor equal to 0, you get 3r minus 5 equals 0, which means r equals 5/3. And for the second factor, r plus 3 equals 0 means r equals negative 3. So 5/3 and negative 3 is our solution set for that problem. Okay, moving to the next example. Problem number 2. This is a difference of squares. Difference of squares factors as n plus 1, n minus 1. Two terms, we'll always look for difference of squares or GCF to factor it. So that's n plus 1, n minus 1. Setting each factor to 0 means that n is either positive 1 or negative 1. So that's our two solutions for that one. All right, number 3, this one we have to first set it equal to 0 because, again, to solve by factoring, we're going to use the zero product property. So x squared plus 5x minus 24 equals 0. The factors of negative 24 that add up to be positive 5 are positive 8 and negative 3. And again, each of those factors equals 0 means x either equals negative 8 or x is positive 3. Okay, then we move into completing the square. Completing the square is the one technique where we don't want the equation to be equal to 0. As a matter of fact, we want to move everything that doesn't have a variable to the other side. So the first thing we would do here is subtract 46 from both sides, and that's going to give us negative 41 on the outside. And the completing the square process requires us to take half of our middle term. Half of 20 is 10. So I want to square that, 10 squared, and add it to both sides. And when we do that, what we create on the left is a perfect square trinomial. In other words, it will always factor as k, in this case, k plus half of 20, again, is 10. So that's k plus 10 squared equals 59. And then we can use the square root property, k plus 10 equals plus or minus square root of 59. Subtract 10 from both sides, and we get k equals negative 10 plus or minus the square root of 59. We can't do anything else with that answer because 59 is not a perfect square, and it does not have a perfect square factor. So that's all we can do with that one, and that's the two solutions. Next example, again, completing the square, we do not want it equal to 0. So we'll have x squared minus 20x equals negative 96. And we'll take half of the middle term. Half of 20 is negative 10. Negative 10 squared is positive 100. So we add 100 to both sides. And then what's on this side is going to factor as, again, half of negative 20 is negative 10 squared equals 4. Now, if you wanted to be convinced that this x minus 10 squared is this, you could just kind of confirm. It's just regular factoring. X minus 10 squared, that's x squared. Minus 10x and minus 10x gives you the negative 20x, and negative 10 times negative 10 is plus 100. So the factorization works. Half the middle term is what you're looking for with that. Now that we have something squared equals a number, we can use the square root property. That means x minus 10 is the positive or negative square root of 4, which is 2. Add 10 to both sides, we get x equals 10 plus or minus 2. Now, 10 plus 2 is 12. 10 minus 2 is 8. So our two solutions are positive 12 or positive 8. All right, next problem. Solve by completing the square. The first thing I would do on this one, because we can, is divide everything by 3. That's going to make our equation a lot easier to deal with. So we'll have b squared minus b equals, if you add 6 to both sides, divide by 3, you get 2. And you actually have to get rid of the a term. If you have anything other than 1 there for this, you're going to do that. So b squared minus b, if we take half of the middle term, our middle coefficient is negative 1, half of negative 1 is negative 1/2. And if you square that, you get 1/4. So we're adding 1/4 to both sides. And that's going to now factor as b minus 1/2 squared equals. Common denominator on the right is 4. 2 is 8 over 4. So 8 over 4 plus 1/4 is 9 over 4. And now we're ready to apply the square root property, which says if we have something squared, then the something inside is equal to the positive and negative square root of the other side. So the square root of 9/4 is 3/2. Then we will add 1/2 to both sides to get b by itself. 1/2 plus or minus 3/2 will give us these two solutions. 1/2 plus 3/2 is 4/2, which is 2. 1/2 minus 3/2 is negative 2/2, which is negative 1. So our two solutions are 2 or negative 1. Okay. The next problem, we're told to solve by the quadratic formula. Okay, the quadratic formula is, in this case, a equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we're going to make those substitutions and do some simplifying. Our b value here is positive 1, so that's going to be negative 1 plus or minus b squared, that's 1 squared, minus 4 times 8 times 10, negative 10. Don't forget the negative 10. You miss the problem if you lose that. Negative 10. So that's going to be all divided by 2 times 8, which is our a value. Now our radicand here, 1 minus 320. Is that right? 4 times 8 is 32. 32 times 10 is 320. So that's actually plus 320. So that's 321. Now, does 321 have a perfect square factor that goes into it? 321 is divisible by 3. 107 times. 107 is prime. So that is all we can do there. Negative 1 plus or minus the square root of 321 over 16. It's an ugly answer, but it is a good one. Okay. Next example, number 8. We need to set it equal to 0. Using the quadratic formula, we have to have our equation equal to 0. So let me do this over here. 8x squared plus 10x plus 9 equals 0. I'm guessing that this one looks like it's going to have imaginary solutions, but we'll work it through and see. We've got x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So when we make our substitutions, b is 10, so that's going to be negative b, which is negative 10. And it's going to be 10 squared minus 4 times 8 times 9, all divided by 2 times 8. And at this point, we've got negative 10 plus or minus 100 minus that thing. Negative 32 times 9 is 270, negative 288. The key is that this is negative. It's negative 188, I think. But it really doesn't matter. It's negative, and so we're going to stop right there and say that this equation has no real solutions. Okay, we haven't taught this yet, but I would even allow it on the test tomorrow. A quick investigation of what b squared minus 4ac is here tells you that b squared minus 4ac is certainly a negative number, and we could jump straight to the fact that we have no real solutions. And that's going to happen a lot of times if everything is positive. Not always, but a lot of times it'll happen if everything is positive. It pulls the parabola up above the x-axis and doesn't have any real solutions. All right, let's look at the next example, 5x squared. Again, 5x squared plus 8x minus 48 is equal to 0. And we're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can hear Nick House singing that right now. So x equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 48. Now see that negative 48 there, that negative c value kind of it ensures us that we're going to have a positive radicand, and that means we're going to have real solutions. Hold on, I made a mistake. A is not 1, A is 5. I don't know if I can do this or not. Yeah, it's not bad. 5. All right. I'm not going to finish this one. Got a big number here. Calculator to do that radicand and finish the problem from there. All right, let's have a look at this one. Now, keep in mind that solving absolute value inequalities are always going to split into two. Less than is and, greater is or. So this less than symbol right here tells us that this is going to be an and problem. The two equations that are going to be generated by this is going to be p minus 4 is less than 6, and the second inequality, p minus 4 is greater than negative 6. Flip the symbol, change the sign. This means p is less than 10, or p is greater than negative 2. Less than 10 opens this way. Greater than negative 2 is going to open and go this way. And we'll see that the overlap takes place in between those two quantities. So your solution is everything between negative 2 and positive 10, not including those two values because the open circles. All right. Now, this says solve by the method of your choice. You have choices here. I'll show you two quick choices because this immediately looks like I can get the squared part by itself. You can divide both sides by 2, and you get p squared equals 25. Then we can apply the square root property and get p equals plus or minus 5. Another possibility here, still dividing by 2, we could then make it equal 0, and p squared minus 25 will factor as a difference of squares, and that's going to give us p minus 5 times p plus 5 equals 0. And that gives us p equals positive 5. This one gives us negative 5. So we still get plus or minus 5 regardless of the method that we use. All right, number 12. Actually, I skipped 12. 12, go back. There we go, 12. I want to set it equal to 0 and try to factor. I always do that because factoring is the easiest way to solve these when you can factor. Now, some of you have already jumped onto the quadratic formula boat, and you might want to use the quadratic formula for this one just because you're getting some pretty large numbers when you do this. But 204 is what you get when you multiply. Excuse me, no, it's not 24, it's 208. So we're looking for the factors of negative 208 that add up to be positive 3. That's going to be a tough one. All right, it took me a second. I paused the video. We know that this is 4 times 52. And we know that 52 is only divisible by, it's 2 and 26 is 4 and 13. So 16 and 13 will be the factors that we're looking for here. Positive 16 and negative 13 would multiply to be negative 208 and add up to be positive 3. So I need to use 4p and p to get the 16 and the 13. 4p multiplies by 4, and p is going to multiply by negative 13, and that's the two factors that would work here. Now, some of you may have had so much difficulty with this problem that you just go ahead and use the quadratic formula. But if you set that factor equal to 0, you get p equals positive 13 over 4. And if you set this factor equal to 0, you get p equals negative 4 as the two solutions. Now, again, you can use the quadratic formula, and with the calculator, that's not a problem. You're going to be taking the square root of a large number in the radicand there, but it works. All right, next example is number 13. We will have 4p squared. Again, I'm going to set it equal to 0. 4p squared plus 9p minus 12 equals 0. Are there any factors of negative 48 that add up to be positive 9? Let's see, 48 is 12 and 4, that doesn't work. 16 and 3, that doesn't work. 8 and 6 is not going to work. 2 and 24 won't work. 1, and I don't think this one is factorable. I've tried enough to abandon factoring, and we'll go to the quadratic formula. So p equals negative 9 plus or minus the square root of 9 squared minus 4 times negative 12, all divided by 2 times 4. I did not write the formula there just for sake of time. Negative 9 plus or minus. We got 81 minus, let's say 48 times 4 is 160, and 32, 192. 48 plus 192 is 48, 192. I'm drawing a blank. 48 plus 192 is 240. So much of that over there, and this is all being divided by 8. Now 240 can be simplified, and we always want to simplify our radicals if we can. 240 is divisible by, let's see, what's the largest perfect square that'll go into 240? It's divisible by 4 60 times. That means it's divisible by 16. 240 divided by 16 is 15. So 240 is 16 times 15. And that will give us negative 9 plus or minus 4 square roots of 15 over 8. Now, we always want to do that because we want to know if the fraction can be simplified. This one can't because these outside numbers, 4, 9, and 8, are relatively prime to each other. So negative 9 plus or minus 4 times the square root of 15 over 8 is what we're going to go with there. And I'm working these really, really quickly, guys, to save your time. But I just want you to know that there could be a mistake because I'm going so quickly. But This last or next example is, again, I'm going to set it equal to 0 because I want to see if I can factor it. If I can factor it quickly and easy, that's the best way to do it. So 8 times negative 12 is negative 96. Let's see, 8 and 12. That's 8 and 12 is 2 and 4 and 3 and 4. Looks like any factors of 96, 6 and 16, 8 and 12 is what we used to get there. That's not going to subtract to be 1. 6, 2 more 2s. I don't know if this is factorable, and I've already spent enough time. Let's switch over to the quadratic formula. So we'll get n equals negative 1 plus or minus the square root of 1 squared minus 4 times 8 times negative 12. That's over 2 times 8. So that's negative 1 plus or minus the square root of, let's see, 48 times 8 is 384. Plus 1 is 385, which is not a perfect square, and that means that that polynomial indeed was not factorable. 16. 385 doesn't look like a number that's divisible by any perfect squares. It may have some perfect squares that would go into it. I'm going to stop right there for sake of time. 385, let's check it. 385 divided by 5 is 48. No, that's not right. Clear. 385 divided by 5 is 77. So 385 is 5 times 7 times 11. No perfect square factors, and that is indeed the simplified answer. All right, next example. 15, again, is another absolute value inequality. The first thing we would do is get the absolute value inequality by itself. So if you add 9 to both sides, you get absolute value 7 plus 2n is greater than or equal to 19. Now we're going to split it. Remember, greater is or. So this is going to be 7 plus 2n is greater than or equal to 19, or 7 plus 2n is less than or equal to negative 19. Now, if you solve each of these on the right-hand side, you subtract 7, you get 12, divide by 2, you get n is greater than or equal to 6. On the right side, you subtract 7, you get negative 26, divided by 2, n is less than or equal to negative 13. So we're going to be OR problems. Just graph them right on the same number line together. Greater than or equal to 6 looks like that. Less than or equal to negative 13. Where's 13 is going to be right here. Negative 13 shades this way. All right, so that's how you do that. So you have to remember to isolate your absolute value, and then you have to remember to flip the symbol, change the sign. Greater is or, less than is and. All right, so number 16 is a radical equation. And to solve the radical equations, they're really similar to absolute values. We're going to get get the radical by itself. So you would move that to both sides and square both sides at this point. You get p minus 5 equals 49. Add 5 to both sides, you get p equals 54. Now, remember to check for extra solutions. Whenever you square both sides of an equation, sometimes you create extra answers. So plug this back in and do a quick check. Is the square root of 49 minus 3 equal to 4? It is, and so that is a good answer. P equals 54 actually works. Okay, number 17 is the absolute value is already isolated for us, so we'll square both sides. And that's going to give us 2r minus 7 equals 9. Add 7, divide by 2, we get r equals 8. So r equals 8. Plug it back in real quick. 2 times 8 is 16. 16 minus 7 is 9. And the square root of 9 is 3. So we are in good shape with that one. All right, number 18. We're ready to square both sides. When you square both sides, the radicals go away, and we're left with 3x minus 3 equals 2x minus 1. Subtract 2x from both sides and add 3 to both sides, and we get x equals 2. Check for extra solutions. Is 3 times 2 minus 3 equal to 2 times 2 minus 1? On the left, we get 6 minus 3, which is 3. On the right, we get 4 minus 2, which is 3. So square root of 3 equals 3 tells me that that is a good solution. All right, next one. This one, we need to, again, get the radical by itself. This one's giving me a little pause right out of the blocks because of the minus x there. We'll have to kind of see if this one works for us. If you subtract 4, you get x minus 4 equals the square root of 4 minus x. Now, if you square both sides, you have to remember that what's going on over here on the left is x minus 4. So when you square that, you're going to get x squared minus 8x plus 16. You have to FOIL it, equals 4 minus x. Now, at this point, we've got a quadratic equation that has shown up, so we're going to have to do one of our quadratic techniques. If we add x to both sides, we get x squared minus 7x. Subtract 4 from both sides, we get plus 12 equals 0. And this will factor as x minus 3 times x minus 4 equals 0, which tells me I've got two solutions, x equals 3 or x equals positive 4. Now I want to go back to my original equation and see which one of these will work. There's a good chance that one of these is extra solution, because we created this square right here. We created two solutions. We wouldn't really expect this thing at the beginning to have two solutions. Sometimes it can, but if we plug 3 in to this equation right here, you get 4 minus 3, that's 1, right? So on this side, you're left with 4 plus the square root of 1 equals 3. That is not true. All right, so 3 is a bad solution. We're not going to keep 3 as a solution. Pretty sure that 4 will work, but we're going to check it because sometimes you actually create 2 extra solutions. Some of these, you start out at the beginning and the problem has no solutions. But if we plug 4 in, I erased it. If we plug 4 in, we get 4 equals 4 plus the square root of 4 minus 4. And that works. 4 does equal 4 minus plus the square root of 0. So we'll keep 4 as our solution, and we're going to reject 3. So you always have to remember to check for extra solutions when you're doing this. And the test tomorrow will have this reminder on it, and I'll also remind you of it in the preliminaries of the test. All right, number 20. Y is less than negative 1/3 x minus 2. And this is a multiple choice test, multiple choice question. I'm not sure that it will be on the test tomorrow, but we've got 1/3 x minus 2, negative 1/3 x minus 2 has a y-intercept of negative 2, slope of negative 1/3. It's a solid line because the greater than, less than, or equal to, and less than means we're going to shade below it. Negative 4/3 x plus 1 has a y-intercept of positive 1. Slope of negative 4/3, that's up 4 and left 3, so maybe something like that. It's a solid line also because we're shading above that line. All right, so if we're above this line, that means we're going to end up, our overlap is going to end up being in this little region here that's below one and above the other one. So I'm not sure which solution that is, but this little shaded region right here is below the purple line and above the red line. All right, and then problem number 21 is parallel lines. So we've got greater than or equal to 5/3 x plus 2. Two parallel lines here. 5/3 x plus 2 is something like this. Up 5 and right 3. Maybe something like that. And that's a solid line. And we're above it. The other one is 5/3 x minus 1, so it's going to have the same slope. It's a dotted line because it's just greater. And we're shading above that one also. So that one's going to be, we're going to be shading above that line also. So we'll be shading above that red line. And you can see that the area where the two lines overlap is going to be this area that is above both of the lines. With parallel lines, we could be above both the lines, below both the lines, between both the lines, or if you end up shading opposite directions, you would have no solutions. So that is the review sheet worked in completion for you. Hope you enjoy it. Thanks.